What is up, Geo Metro Ninjas? Welcome to another spectacular day in geometry. So, today we get to talk about area and circumference of circles. Now, this isn't the area and circumference you guys might have learned in third, fourth, fifth, sixth, seventh, eighth, ninth, all the way to where you are now, of just applying, hey, there's a circle, let's apply our area circumference formula. What they're going to do is they're going to either circumscribe a circle inside of a polygon, or they're going to inscribe a polygon within a circle, and then ask us to use our special rights, the Pythagorean theorem, maybe even a little SOHCAHTOA to help us find the area and circumference of our circle. Because at the end of the day, what we're trying to do is strengthen our skills. And that's what all of our lessons have been. Can we strengthen our skills in 30, 60, 90s, in 45, 45, 90s? Can we make ourselves be the absolute best version and absolute rock stars when it comes to solving those ratios? So this should be something familiar to you. Okay, the area formula of a circle. Area is pi r squared. Remember, the radius goes from the center to the outside, and diameter is from the outside all the way to the other side, passing through the center. My picture kind of got a little wonky there. Let's see if I can move it on over. Nope, she don't like it. Okay, we're good. And then circumference, there's two options. You have circumference equals 2 pi r, or circumference equals pi times diameter. Guys, remember, diameter is just 2 radii. So that's all 2 pi r is doing. That's why there's a 2 pi r, and then the other one is just pi d. Because if we have the diameter, we have 2 radii. All right, let's look at number 1. So number 1 is a circumscribed circle within what looks to be a square. We're not really sure, but we know that that top side is 8 centimeters. If we were just to come down here and go across the center of our circle, now that should be a congruent line because my line would be parallel, okay, which makes this whole line 8 centimeters. And then I'm guessing you guys at home already know each half line is 4 centimeters. Okay, so now that we know our radii and our diameter of our circle, we're going to go area equals pi r squared. We're going to substitute that radius, so pi times 4 squared. We're going to square the 4 only because that's who the square is attached to. Notice we don't have parentheses squared. We just have 4 squared. So we get 16 pi centimeters squared. And that's where we're going to leave our answer. That's it. That is an exact answer in terms of pi. Kind of like simplest radical form. And the circumference is 2 pi r. Substitute that same r, 2 times pi times 4. So we get 8 pi centimeters. Or, of course, you could have done circumference is pi d, since we know the diameter. So pi times 8. So again, 8 pi centimeters. So depending on what you have is your circumference formula. If you're a person that's always comfortable saying, hey, let me rock and roll with my radii, go for it. Nothing wrong with that. All right, number 2. Now we have a inscribed polygon, and that polygon has a familiar shape. That shape should look awfully familiar because it is a right triangle. And it is a right triangle in which we know 2 of 3 sides. You guys remember, if we know 2 of 3, we're going to rock and roll with our homie Pythagoras. I tried to make it rhyme. That's not his name. His name's Pythagoras. He came up with a pretty cool theorem. Okay, so a squared plus b squared is c squared. In this case, x is our c because it's across from the 90. Hey, that one did rhyme. Okay, so 18 squared plus 24 squared is x squared. 18 squared is 324. 24 squared is 576. 324 plus 576 is, in fact, 900. And then to undo that square, we're just going to rock with our square root. So the square root of 900 is, of course, 30. Okay, so now that we know our circumference is our diameter, excuse me, is 30, that means each of our radii are 15 because the circumference, our diameter is half the radius. We can go area is pi r squared. So pi times 15 squared, 225 pi, and they didn't give us a unit, so we can always drop in a unit squared. Make sure we keep our chemistry teachers happy by using our units. And circumference, because I have the diameter, I'm just going to rock with pi d. So pi times 30. So my circumference is 30 pi units. So remember, area is square because it's the number of squares inside of our figure. Circumference is linear, just like perimeter, because it's the distance around our circle. Right. Number 3. Oh boy, there they are. You knew it was coming. I put it in the introduction. There's our friend, the old 30, 60, 90. Looking at this triangle, what they gave us was they gave us the long leg because it's opposite the 60. And then we need our hypotenuse. So that's our ratio. Root 3. All we're worried about, so the short leg doesn't come into play here. Because remember, our ratio, let me try to write in a pen, not a highlighter, that might work. Our ratio is 1, root 3, 2. But because we're not worried about the short leg, we can go ahead and get rid of that. Okay, so root 3 over 9 root 3 equals 2 over x. When we have a number on top of itself, basically it is a number divided by a number, and any number divided by itself is 1. So now we can cross multiply. So x is 18. So the whole diameter is 18, which means our radii are 9. Oh man, that thing's jumping all over the place. So area is pi r squared. Oops. So pi times 9 squared. So 81 pi. And again, keep our chemistry teachers happy, units squared. And now we can find circumference, pi times diameter. I'm choosing to use the diameter because I know the diameter. If I knew the radius, I would just use the radius. Okay, so pi times 18. So it's 18 pi units. And if I need to apply that pi, there's a button on my calculator. I just hit that. It's right above the division sign. You would hit second, and then the caret. This is what a caret looks like. We're not talking about Bugs Bunny caret. So second caret would get you to your pi button. All right, number 4. Oh boy, another one of them inscribed polygons. And this again should be a familiar friend. I've got 4 congruent sides. So it's either a square or a rhombus, but it makes it a square because of the right angle. So this is a square being inscribed, meaning each vertex is on the circle within our circle. So again, I need x, which is our hypotenuse. So 1 root 2 is 7 over x. Now this problem is going to test our PEMDAS and our old exponent rules. So we're going to cross multiply. So we get 7 root 2 is our diameter. Now, those of you playing at home, you see what's about to happen because our diameter is half the measure, or the radius is half the measure of our diameter. Those of you that have already foresaw the future, you know it is 7 root 2 over 2. We don't want to use the decimal here. And you guys are going to see why we don't want to use that decimal when we go to put this into our area formula. Guys, don't be afraid of fractions. Fractions are your friend. Okay, so area is pi r squared. So looking at this problem, I've got pi times my radius squared. So 7 root 2 over 2 squared. Now this is what we're talking about. We're going to push those algebra skills. If you think back to maybe 8th grade or 9th grade you, sitting there wondering what in the cheddar cheese is this person talking about an exponent. At one point, they said, hey, if there's a fraction, make sure we apply the exponent to all the participants. So this square is going to get squared to the 7. The square root 2 is going to be squared, and the denominator is going to be squared. So that square is like a superhero. It's going to get touch every single person. So here we go. We're going to go in slow-mo. Oh, no, I'm just kidding, guys. We won't do that. Okay. So 7 squared is 49. The square root of 2 squared, when you square a square root, disappears. And then over 2 squared, which is 12. Okay. So now we have pi times 96. Nope, 98. Sorry, 98. Trying to do math in my head. 98 over 4. Reduce that fraction. Hey, remember, you have math frac. You don't got to try to do it on your own. So we get 49 over 2 pi inches squared. Now that was a fun math problem. I love me some algebra. So this is definitely going to be a spot where I want to use the diameter, because some of you guys just don't like fractions. So if you can avoid them, you're going to avoid them. But pi times the diameter. We know our diameter is 7 root 2. So we get 7 root 2 pi inches. Number 5. We've got a equilateral triangle being inscribed within our circle. If that thing is a radius, meaning from the center to the vertex of that triangle, it's going to bisect that angle, and it's a radius of our circle as well. So this is our short leg, and we need the hypotenuse. So 1 over 5 is 2 over x. Cross multiply, so x is 10. Perfect. Now we know our radii is 10. So area is pi r squared. So area is pi times 10 squared. Area is 100 pi units squared. Keep your chemistry teachers happy. You want them on your side. They know where all the good stuff is. Okay. And then circumference is 2 pi r. Again, I'm using r here because I don't automatically have the diameter. So 2 pi times 10 is 20 pi units. All right, we're going to do one more problem together. We are going to reverse engineer one of our formulas to find enough answer for the other. So number 6, find the area of a circle if the circumference is 10 root 2 pi. Okay, so they want us to find area. So when we look at our area formula, we know that we need the radius. Okay, we need to be able to square a radius. So we're going to use the circumference formula that finds us a radius. Circumference is 2 pi r. We want to solve for r in this situation. Okay, so we're going to substitute 10 root 2 pi is 2 pi r. We are solving for r, so we're going to get everything that's attached to r away. So we're going to go ahead and divide both sides by 2 pi. Kind of write that out so you can kind of see. Pi divided by pi cancels. Any number divided by itself is 1. That's why this cancels out over here. You're dividing it by itself. It becomes 1. And then 10 divided by 2 is 5, leaving our root 2. Remember, when we're adding or we're multiplying or dividing, outside, outside, inside, inside. There's no inside to reduce that root 2, so it's got to stick. Now that we know our radius, we're going to go 5 root 2 squared. Right? Remember, when we square both. So 25 times 2, okay, because when you square a square root, it becomes nothing. It cancels out. So our answer is 50 pi inches squared. Guys, that is our lesson on circles. We took what we knew with our basics and we applied it to what we've been doing. You guys are awesome. You guys are rock stars. Go be great today.